So I will write a new page and using a different problem from the quiz, it is the universe is still 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The topology is the empty set 1, 3, 5, 2, 4, and the universe. And the universe and the sequence is 1, 3, 5, 1, 3, 5. So very quickly, let's just use that thought I had before. So if it contains the sequence, in the open set, it'll be good. This one contains it, 1, 3, 5. This one does not, and then this one does because it has 1, 3, 5. So those should be good, and this one does not. So I'll predict very quickly that 1, 3, and 5 will converge, but 2 and 4 will not because they have an open set that does not contain this sequence. But let's just go very quickly. So let's test out 1. To see if 1 converges, every open set that contains 1 must be tested. And we have this set and the open set. So let's go with the first one. The first one is 1, 3, 5. So as you can see, they're not connected. And the sequence goes 1, 3, 5, 1, 3, 5, 1, 3, 5, and it continues. As you can see, it stays within the boundaries. So it's good so far. And then the next one, the universe, also has 2 and 4. So it can now land in 2 and 4. And if it does, it'll be fine. But as you can see, the sequence is still 1, 3, 5, and it still contains it. So it converges to 1. 1 is good. If we want to check 2, any set that contains 2 now must be tested for its convergence. So this one does not have 2, we don't have to test it. This one doesn't have 2, we don't have to test it. This one has 2. So the only boundaries we have are 2 and 4. And the sequence goes 1, 3, 5, 1, 3, 5. And as you can see, it does not even touch the sequence. And that's what Dr. Garcia was saying, that it could go in and come out, in and come out. In this case, it doesn't even really touch it if we're jumping. But even if it were to go in, right, like right there, and it goes out, it has to converge eventually. So it doesn't matter if the sequence was 2, 4, 2, 4, 2, 4, if it ends up becoming 1, 3, 5, 1, 3, 5 at the end, because as you can see, it'll go in, I'll draw the snake, in, but then it doesn't stay in anymore, it just goes out. And the little drawing he made was a circle with the open sets and the dots going in and out, and it has to stay in, he said. Except right here, I'm using a drawing with boundaries, kind of, to emphasize these numbers a bit more. So once you find one that it does not work, it will not converge to that number. And just real quick, so we can see if 3 and 5 work, because 2 and 4 have the same number. Well, actually, we don't really have to, because 2 and 4 have the same set that doesn't work, then we know 2 and 4 will not work. And because 1, 3, and 5 share the same open sets, we know that 1, 3, and 5 will work. So as you can see, we predicted correctly, because we knew that this sequence only works in this open set and this open set. So thank you for your time. I hope this recording is not too long. I kind of jittered, but hopefully the visuals helped you see a bit more like, oh, it has to be within the boundaries. And remember, it doesn't just have to be in, but the ending has to end off there. Actually, let me check for one problem. So I didn't really see a problem I would have liked to show, but I made this one up real quick. So we have our universe, our topology, and the sequence. So as we can see, this sequence, the only one that contains 1, 2, and 3 is right here, the universe with 1, 2, 3, but the sequence will only repeat 3 after here. So when we test for 1, these are our boundaries. It goes 1, 1, 1, then it goes 2, and it stepped out. 3, 3, 3, it does not converge to 1 because we found one where it does not converge. And you might be thinking, again, like none of these contain the 1, 2, 3. But if we go over to number 3, we will see that it converges to 3, or it should, because the line would look like this. And let me erase these so you don't think those are our boundaries. As you can see, the line converges to our boundaries. And again, that's what Dr. Garcia was saying, when it could go in and out. And then once it goes in, it stays forever. Although it didn't go in and out here, we'll see that it converges to 3 because the set actually has 2, 3, and the universe 1, 2, 3. We see that all the open sets, this line ends up staying within the open sets. And just to show an example of when it could go in and out, I will change my pattern at the end here to 1, 1, 1, 1, 1, just so it's clear that we're going to be repeating 1 forever after that. So allow me to erase these. So our range will only be 1 because we are checking for this one because it contains 1. And we see the pattern is 1, 1, 1, 2, 2, 3, 3, 1, 1, 1, 1, definitely. So now our pattern went in and out and back in, and it stayed in. So therefore that one is good. This one does not contain 1, and this one contains 1. So our new range will be 1, 2, 3, and it stays within that area again. So that one is also good. Therefore it converges to 1.